Hey guys, this is actually the last day of graphing new functions that we're going to look at today. So we're doing our cotangent and our tangent. And I think this is probably the hardest day of graphing because the things that we're going to do today are a little bit different. So cotangent and tangent, those functions in general look different than the sine and cosine functions that we've been looking at, and cosecant and secant. So cosecant and secant are the same as the sine and cosine, except for that one little added twist where we have those asymptotes for sine and cosine are 0. Cotangent and tangent look like different functions. So the process for actually finding them is a little bit different. To start out, we're going to do what we did when we started doing cosine and sine, which was actually making a table and looking at the values. So I want you to think about cotangent as terms of sine and cosine. So we know tangent is sine over cosine. So cotangent is cosine over sine. And there is a reason, I know it seems kind of funny that we're starting with cotangent rather than starting with tangent, but there is a reason that we're starting with cotangent, and the reason is that it's most similar to the graphs that we've been doing, or at least the steps are the same. So this is actually not throwing too much of a wrench into things. It looks a little bit different, but the process is generally the same. But when we graph tangent, the process is kind of different. And it's the only graph that is different like that. Okay, here we are. I'm going to draw a little unit circle off to the side just to remind myself. So at these values, which we're going to look at really only for cotangent, we're only looking from 0 to pi. And that's really like the normal period of cosine and sine is 2 pi, but for cotangent and tangent, it's actually only pi. And the reason is because for cotangent and tangent, to get back to our beginning values before we start to repeat, it takes all the way around our unit circle, because like here our cosine is positive, and then it's negative, and then it's negative again, and then it's back to positive, so it takes the entire way around. But for cotangent, since it's the ratio of the cosine and sine, it's positive here in quadrant 1, it's negative in quadrant 2, and then once we get to quadrant 3, it's positive again. So it actually just repeats in this cycle, and then it repeats again in that cycle. So the period is only actually pi before it starts to repeat versus our normal 2 pi. And I'm just going to write out the quadrantal ones, and then we'll figure out the other ones. So at our 0 value, we're at 1, 0, and at our pi over 2, we're at 0, 1, and over here at pi, we're at 0, or negative 1, 0. By the way, I am recording this at 9 p.m. on Thursday after getting home at 8:45 all day. So be on the extra lookout for all the mistakes that I might make this video, because there might be a few. Sorry about that. It's been a day, that's for sure. Let's see. So if I'm looking at, and I'm also kind of having a little allergy attack, so sorry if I'm sniffly. So at 0, if I look at that value and I plug in and evaluate my cosine and my sine at 0, so the cosine I know is 1 and the sine of that value is 0. So when I actually evaluate then cotangent of 1 over 0, that's an issue with our domain. So that actually appears as that asymptote. Now that should make sense, and I want to remind us all of the domain and range for cotangent, because for this next test you need to know the domain and range for everything. Shouldn't be that hard, but since we've known the domain and range for most of these things, now we just have to remember them all together. For cotangent, our domain has to exclude some values because we have those problems with our denominator. It's actually the same domain as cosecant, which we just talked about last video. So our domain is negative infinity to infinity, except we have to exclude the places where sine is 0, and that happens at 0, it happens at pi, it happens at 2 pi, it happens at 3 pi, it happens at 4 pi. So we're excluding all those k pi values where k is an integer. and range we're going to look at here in a second. So that's at least our domain, and so that's why we have these asymptotes at 0, and we'll have another asymptote here at pi. So if I look at that value, if I try to plug that in, I'll get -1 on top and 0 on the denominator, which is why I'm getting an asymptote here at pi. Okay, so at pi at 4, my cosine is √2/2, my sine is √2/2, so my cotangent value here is 1. At pi, my cosine value is 0, my sine value is 1, 0/1 is 0. And at 3 pi over 2, my cosine value is -√2/2, and my sine value is positive √2/2, so my cotangent value is going to be -1. So we have these asymptotes again at 0 and pi. So for our cotangent functions, when we have our 5 critical values, just from 0 to pi, because that's our normal period, our asymptotes happen at the first critical value and the last critical value. So we always know that like it's not always going to be 0 and pi because we have phase shifts that go along with it. But for now, like you can kind of think about it as our first critical value and our last critical value. Right in the middle, between my third critical value, and this is actually kind of the same for our tangent graph too, between my 2 asymptotes, I have a 0. So that will happen when we have like a vertical shift. That might be on our new baseline, but we'll always have like a 0 at that value. And for cotangent, at pi over 4, we're at 1. At 3 pi over 4, we're at -1. So the way this looks, I'm bad at drawing cotangent from this angle. It's kind of this like weirdo sideways S shape. So if I'm analyzing my range of this thing, what's my lowest value? Well, I have an arrow going down to -infinity, and then I have an arrow going up to positive infinity. So my range for cotangent and tangent 2 will be -infinity to infinity. And again, it's kind of this like sideways S. All the steps for graphing cotangent is the same, except for one little thing, is that your period is actually not just, isn't 2 pi over b, it's going to be just pi over b. But everything else is exactly the same. Like you just have to remember your asymptotes at the first and fifth, your 0 at the middle, and then you'd go like up your amplitude and then down your amplitude for those cotangent graphs. So let's practice a couple. So I'm still going to kind of create my little list off to the side here. So I have my amplitude, I have my period, I have my starting x, I have my ending x, and then I have my vertical shift. So my amplitude for this thing is outside of my cotangent, so that's going to be 3. My period has to do with my b value. So normally cotangent tangent has a period of pi. So instead of 2 pi over b, it's going to be pi over b. So in our case, pi over 1/4, which is another way of saying pi times 4 over 1, which is going to be 4 pi. We don't have anything after the x, like a plus pi over 4, a plus pi over 8, or a minus 3 pi over 8, or whatever it is. So our starting x value is going to start here at 0. And the ending x value is going to be 4 pi. Remember, our starting x and our ending x for cotangent, that's going to be where our asymptotes are. In our vertical shift, we don't have a plus on or a minus on either side, so our vertical shift is none, or 0. Okay, so let me label my x-axis here. So I'm starting at 0, I'm ending at 4 pi. I have then the average, so that's like my first critical value, my fifth critical value, average of those is going to be 2 pi, that's my third critical value. Just like normal, this is going to be pi, and this one, the average of those is going to be 3 pi. Graphing again is the same, the only difference is that we have these asymptotes at 0 and 4 pi, which is our first and our fifth critical value. We always have a 0 right in the middle, our third critical value for cotangent. And then we would go up and down our amplitude. At our first critical value for cotangent, we're going up our amplitude, up to the left, and then down to the right. So it looks something like that. or cotangent. Okay, let's try again, except we're going to have a few more transformations. So here's our amplitude, our period, our starting x, our ending x, and our vertical shift. So our amplitude is in front of that, so that's going to be 2. Oh, just as an FYI, if I were going to have, like, both of these are dealing with a positive amplitude, I don't have like a -2 or a -3, but if I were to have a reflection, instead of going up, I would be starting down, and then I would be going up this way. So I'd have an S that would be going up to the right rather than down to the right. So just as a warning. Our period is pi over b. Here's our b value right here. So it's going to be pi over 2. Our starting x value, it's nice of me that I've already factored this out for you. So this is negative pi over 2. And our ending x value, same as before, we take our starting x value, negative pi over 2, and then add on our period, which is pi over 2, and we get our starting value of 0. And last but not least, we have a vertical shift right here of up 1. So our graph is kind of primarily left of the axis. So I'm starting all the way over here at negative pi over 2, ending at 0. And then I need to find, again, the averages of those two values to get my third critical value, of these two to get my second, and then these two to get my fourth. Oh my gosh. Okay, so negative pi over 2 plus 0 is negative pi over 2 divided by 2 is negative pi over 4. Let's try again. I'll do this one first because that one's easier. Negative pi over 4 plus 0 is negative pi over 4 divided by 2 is going to be negative pi over 8. Negative pi over 2, which is negative 2 pi over 4, plus negative pi over 4 is going to be negative 3 pi over 4 divided by 2 is going to be negative 3 pi over 8. Remember, cotangent has critical value or asymptote at my first and last critical values. So there are my guidelines to draw my S shape through. I've got a 0 here at my third critical value, but don't forget we do have this vertical shift. So before we actually do put in our zeros, make sure that you draw your new baseline. I almost forgot that, but I caught it. Good job. So that's going to be our new 0 on our line, and then we are going to go up and down our amplitude from there. So up 2 units and down 2 units from our new baseline. And remember, cotangent starts and goes down to the left. So at 3 pi over 2, we're going to be up 2 units from there, and then at negative 3 pi over 8, I think I said 3 pi over 2. I meant negative 3 pi over 8, and then at negative pi over 2, we're going down to kind of right on my values. And there's my cotangent. So don't get confused with like the range for this. Our range is always still negative infinity to infinity. These values before were kind of important because those determined our range for cosecant and secant and cosine and sine. But right now, our range is still these values that just are negative infinity to infinity. This just tells us like where to actually plot those points. Okay, this is the easier part of today's lesson, is graphing cotangent. The harder part, it's a different shape, and it's easy to forget that it's pi over b rather than 2 pi over b. Cotangent, tangent, both of them have that same idea, so we still do pi. But this one's the easier one because all the steps are the same. We still make this little table off to the left. We're still looking at starting x value, ending x value. We still have all those same transformations. Tangent, though, is a little bit different. So our tangent, we're going to do the same process where we're going to write it as a ratio of my trig function. So tangent's going to be sine over cosine. And so right now, since we're on the right track of dealing with our domain and range, let's think about what our domain of this thing's going to be. So our domain actually is the same as secant for this because cosine is in the denominator. That's how we can tell we have an issue, because we have a divide. We could potentially have a divide by 0, and we will at particular values. So at those particular values, we need to exclude them. So we are going to have everything except for the values that will give 0. Cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, all the k pi over 2, where k is an odd integer. We got to exclude those. It's a little blurry. That's a little bit better, maybe. Maybe not. Our range is actually the same as cotangent, and we're going to see that in a second. So negative infinity to infinity. So for tangent, we are only looking at negative pi over 2 and pi over 2. It's kind of a long story, but this is actually called our principal range. So like these are if you actually did an inverse tangent in your calculator, you would only get the values between negative pi over 2 and pi over 2. You know how your calculator only gives one of those ratios, one of those angles that would give that ratio, and then you have to calculate the other one. It all goes with like a principal domain, or a principal range, excuse me. And that's really like the range of my inverses. But in actuality, it's because we have our asymptotes at these values. Like if I look at pi over 2, that's really looking at 0 and negative 1. We've already talked about that. Or at least we talked about the pi over 2, which is at 0, 1. And if I try to calculate tangent at that value, I'll have our sine value, which is 1, over our cosine value, which is 0. So I'll have asymptotes here. So I can't have like this half of my plane to give values out. Like if I do my inverse tangent, it wouldn't make sense to include that because I'm like breaking it up at these asymptotes, but it's defined everywhere in here, which is why it's from negative pi over 2 to pi over 2. You really don't need to know that. That's just a little bit background of like why this one's starting different, like why we're starting at different values versus just starting at 0 here and then going forward. It's because we have like this asymptote that goes, like we want to kind of have our graph between the asymptotes, and this one has asymptotes at these ones rather than 0 and pi. It's just like shifted pi over 2 units. So again, it's kind of like the same graph here, but we're like shifting it this way. Okay, anyway, at negative pi over 2, that's down here in this quadrant 4. So at negative pi over 2, that's going to mean pi over, or root 2 over 2, negative root 2 over 2 over root 2 over 2, which is going to be negative 1. At 0, we're at the values of 1, 0. So our sine value is 0, our cosine value is 1. So 0 over 1 is going to be 0. And then at pi over 2, we're back to 1. So we're getting the same table again, kind of slightly different. We're starting here at 1 and then going to negative 1. So it actually, instead of going down, tangent will actually be going up. And our asymptotes are just at different x values. So we have asymptotes at negative pi over 2 and pi over 2, which is kind of like our first and our last critical value, but we always start with our critical value of 0. So it's actually like our first, well, it's actually like if this is usually our first critical value, it's like 2 less than that, and then our like third critical value. So the way we actually calculate these ones is different. I'll explain that more on the back. We have a 0 at 0, 0. And then at negative pi over 4, we plot our point at negative 1 and then positive 1. So again, it looks like this kind of like S shape. And again, our period is actually a complete pi. We just have, and this is kind of important, tangent is actually symmetric. On both sides of the x-axis. So half of our period is to the left of like our starting value, and our starting value is usually 0, but if a phase shift happens, like if I have Moving to the left, pi over 4 units, my 0 would actually be here. So that's like our starting value is actually the 0 here, which is important because usually we graph it like then we find our ending x value by adding our period on, but we only are adding then like half of our period onto this starting value and then subtracting our period to get like our value on this side. So it's symmetric about our y-axis here. It's symmetric about this middle point, which means that we have half of the period on both sides. It's symmetric on both sides of the x-axis, and we have half the period on both sides. And our period, remember, like if this is pi over 2 and this is pi over 2, then our whole period here is pi. So in general, to find our period, we again do pi over b. So graphing tangent is definitely different because our starting value is actually in the middle and we have to go on either side of it. So actually graphing it and like finding the process, we don't make the same chart that we do for every other function. So this is the only one that's different. Sorry, this is going to be a longer video. I'm talking too much. Okay, so let's start with one example. It's a little bit easy. So for our amplitude, we just have 1 because we don't have anything in front of the tangent. We're going to find the period. So period for tangent is pi over b. Our b value is in front of the x, so this b value is actually pi over 8. So pi over 8, which again sounds a little bit weird, but it's okay. It just means that our values are going to be whole numbers rather than in terms of pi, excuse me. Okay, so then I have pi over 1 times the reciprocal, 8 over pi. Our pi's cancel. We're left with 8. Great. I don't have any phase shifts. I don't have any vertical shifts. So for this easy example, it's kind of, this is why we're starting with this easy example, is so you can see kind of how this symmetry works. So our starting value then, I guess I will write that, starting x is going to be 0. But our ending x is not 8 because it's not, the entire period is not from our starting value to our ending x value over here. Our period is actually split up over across from our starting value. So we take our starting value and then we take half of the period on either side. We go halfway this way, and then those are our asymptotes for our graph. So if our starting value is 0 and I know that my entire period is 8, I want to take half of 8, which is 4, and that is going to go on this side and on this side from our starting value. So we're going to take 0 and add 4 to it, which is going to be 4, which is easy. And then we're going to take that 0 and then subtract 4 to it, or from it, and that's going to be our ending value on this side. So all together we have a period of 8, but it's symmetric around our starting x value. So very different from what we've done in the past. After that, though, we graph kind of the same way. So like we find the average, we get positive 2. We find the average over here, we get negative 2. And then just like cotangent, our asymptotes are surrounding it. So we have an asymptote, I guess I'll use a different color. I have an asymptote at negative 4. I have an asymptote at 4. I have a 0 in the middle, same as cotangent. Cotangent actually starts up and then goes down. Tangent's the other way around. It's a reflection, basically, of cotangent. So we're starting at, oh gosh, here I'm already messing up. We're starting at negative 1 here and then going up to 1. So ignore that one. That was my cotangent flip. And tangent goes up and to the right. So cotangent and tangent have very similar graphs. Tangent and cotangent, though, are reflections of each other. Okay, so let's try a little bit of a harder one. And the way we're going to do that is we're actually going to look at our period change before we do our phase shift. And the way we're going to do that is like drawing like a separate little x-axis, and that'll help us keep things a little bit straighter, so we don't have to worry about that as much. Okay, so the only thing I'm not going to include in this list is the ending x value, because that's different. Okay. I guess you could say, instead of starting x, I'm going to change this to middle x. And that will be the only difference then when we graph tangent versus all of our other ones. It's the only one that has that middle x because it's the only one that's symmetric around that value. But this really just ends up being our phase shift. So our amplitude is 3. Our period, here's our b value, pi over 12. So our period is going to be pi over pi over 12 rather than 2 pi over our b value. Which again, just like we did above, it's going to be pi over 1 times the reciprocal, so 12 over pi. So those cancel and we get 12. Okay, so I'm going to pause there, and I'm going to figure out my period change before I factor in my phase shift. So that means that I'm going to draw this like mini little x-axis off in the corner. I'm going to start at 0 because that's normally what I would do. And my period and all encompassing here is 12, and I want 12 on either side. So I'll do it off to the side here. I want to take half of my period, and I get 6. So I want to go forward 6 units and then backward 6 units. So this would be normally before we did any sort of phase shift. However, we do have a phase shift because we have a +2 in here, which we know actually moves it to the left 2 units. So our middle x is not going to be 0, it's actually going to be -2. Well, how do we get there? We take the 0 and we subtract 2 to it. Well, if I'm going to subtract 2 from 0, I better be consistent and subtract 2 from everything else. So now my new x-axis, if I subtracted 2 from everything, that middle value, we know we want it to be -2 because that's where our like middle x value is. That's my phase shift here. But my other critical points or critical values, I'll have -6 minus 2, which is going to be -8, and then -6 or +6 minus 2, which is going to be +4. So that's actually my critical values that I want to put on my real x-axis. So before I actually like draw my graph, we want to adjust for we want to do the period change, like figure that out, and then figure out our phase shift from there. I'm going to run out of room. Maybe we'll skip this example and just do this one. This will be like extra practice. If you want to do example 5, you can do that for extra practice because this video is already getting too long. I need to go to bed. That's supposed to be a joke. Math is really important. Here I am doing math, even though I'm tired. That's just how life works sometimes. Sometimes you just gotta do what you gotta do. I know you're probably like, it's only 9:25 by now. Like, you're crazy, Miss Shafford. But you know what? I'm old, and I go to bed early. And I'm also rambling. So here we go. Let's do some math. Here's my new x-axis. Sorry. Here's my new x-axis. Just like cotangent again, we have our our asymptotes at -8 and +4. Now our like first and our last, and we can find then the averages between our critical values to come up with our second and our fourth. So -8 plus -2 is -10. -10 divided by 2 is -5. Great. -2 plus 4 is going to be +2. +2 divided by 2 is +1. Again, like cotangent, tangent has that 0 at our middle critical value, which is, in this case, -2. It's our third one. And unlike tangent, for our amplitude, instead of starting up and then going down and to the left, we're starting down. So at -5, we're starting down at -3, and then at 1, we're going up to +3. Oops. Missed my value a little. So there's like our kind of S shape. It's not the best tangent function I've ever drawn, but that's a little bit better. It'll do. It'll do, pig. Okay, so I'm going to skip example 5 because that's less complicated than this one, and I want to get to that one, and it's already long. So again, amplitude, period, and in this case we're going to like figure out our middle x value. It's the only one that has that. It's the only one that's different. So if you can remember that tangent is different and flies against the pack, then you'll be able to at least remember we have to do this like weirdo x-axis with it. Our amplitude in this case is 2. Our period change is, or our b value is 3, so our period is not 2 pi, but pi over 3. It's, again, nicely factored out for you. That's kind of nice. Our middle x value is really our phase shift. So this is minus pi over 4, so we're going to have positive pi over 4. We're going to move it to the right. I'm even going to put a little plus there so that I know. And my vertical shift is going to be up 4 units. So before I start to like draw actually my grid, I am going to figure out this phase shift and how that actually affects what I'm dealing with. So remember, like our period, my period, and then my phase shift and how that affects it. My period, remember, is split up evenly over my axis of 0. So if my whole thing I want to make pi over 3 units, I have to go halfway over here and halfway over here. So if I take pi over 3 and I divide it by 2, that means that I'm going pi over 6 units this way and negative pi over 6 units to the left. That's like what I'm starting with. So I know my middle x value is not 0, it's actually pi over 4. So to get there, I have to add pi over 4 to 0, and then I have to add pi over 4 to pi over 6 and pi over 4 to negative pi over 6. Okay, fractions are hard, so you can use your calculator, but for this one, we would have to get a common denominator, lowest common denominator, because I don't have a calculator on me, so we're going to do this by hand. This would be 2 pi over 12. This would be 3 pi over 12. So all in all, that would be 5 pi over 12. Hopefully I'm doing this all right. You'd get pi over 2 in the middle, or sorry, pi over 4 in the middle here. Negative pi over 6 plus pi over 4, so that's going to be negative 2 pi over 6 plus 3 pi over, negative 2 pi over 12 plus 3 pi over 12 is going to be positive pi over 12. Someone double check that in your calculator, make sure I'm not making too many mistakes, but I think that's right without actually writing it all down. These should be our critical values, our first, third, and fifth critical value on my x-axis. Oh gosh, I was thinking all those were negative. So here we are, we're going to be over here. Oh gosh. Okay, pi over 12, 5 pi over 12, and pi over 4 here in the middle. And we're going to get our values, our averages on either side. So let's average these. Pi over 12 plus 3 pi over 12 is going to be 4 pi over 12 divided by 2 is 2 pi over 12, which will reduce down to pi over 6. Again, you can find your averages totally in your calculator. I just don't have one on me, so we're going to do it this way. Pi over 4 is 3 pi over 12 plus 5 pi over 12 is 8 pi over 12 divided by 2 is 4 pi over 12. That will reduce down, divided both by 2 will be 4, I guess. What did I say? 4 pi over 12, so it'll be pi over 3 for that one. Again, double check me. Make sure that I'm getting my critical values right, because you never know. We have a vertical shift of up 4 units. So that's going to be my new baseline. And we have an amplitude of 2. So from that new baseline, we're going to go up and down 2. We have our asymptotes at our critical values, or our first and our last. We have a 0 at our middle one at pi over 4, which is our phase shift. Remember, you can always kind of check that and make sure that you're going okay. And then we are, for tangent in general, we start down and then go up. So we would be going down 2 units from our vertical shift of 4, and then up 2 units from our vertical shift of 4. So there we go. Again, I think that graphing our tangent function is definitely the hardest because it's the one that's most different. Cotangent is something that like you can figure out. It's like pretty much the same except for a period of pi. And so instead of doing 2 pi over b, you're going to do pi over b. But tangent is like really different with this whole like symmetric about this 0 point, this middle point. And it's the only one like that. So if you can remember tangent's different, hopefully that will help you like figure out this process.